Okay, this is Lab 3, Part 2. So here they're asking us to solve. There is no distributive property. There are no like terms. So not like terms, not like just one term over there. I want to get the x's together on one side, so it looked like it would be easier to put the x's on this side. When you're doing that, the only choices you have are to add and subtract when you're trying to get the variable on one side and the numbers on the other. So I'm going to be adding 8x to both sides. So I'm going to have negative 54 equals 6x. And then I'm going to be dividing by 6, so that'll be my last story. So negative 54 over 6 equals 6x over 6 here, so that just get x. So that's going to be negative 9. So x equals negative 9 is the answer there. That one was multiple choice. No distributive property, so I'm going to be no like terms to combine, right? So I'm going to be taking away 7 to get the numbers together on one side. So when I do there, I get 23 take away 7 is 16. And then I'm going to be dividing by 8. So x is 2. And it is a really good idea to check these problems. And so you would want to plug in negative 9 here. And then check that this, when you use your calculator, see negative 54, take away 8 times negative 9. This side is 18. And verify that this side over here, when you do the arithmetic, is also 18. And that gives me a good idea that, hey, I did it right. And I'd want to check my answer here too. So I write exactly the original, put parentheses where I have x, I'm plugging in 2. So this is going to be 16 plus 7, which is 23. So both sides are equal to 23, and now I can feel fairly certain that I have the right answer on those. Okay. This one has fractions in it, number 10, and I would clear the fractions is what I would do. So there are 3 terms here. 2 of them have fractions. And so step 1 is to use the distributive property. There is no distributive property. Clear fractions if you got them and you want to, and I do want to clear fractions. The common denominator is 56. So I'm going to be multiplying 7 over 8 by 56. I'm going to be multiplying 1/7 t by 56, and I'm going to be multiplying the 2 by 56. All of them by 56. So I got a different color pen here. By 56. Here by 56. All of them distributive property, right? I'm doing this side by 56, so you distribute. This side by 56, there's only one thing over there. And so it's all of them because of the distributive property, and I'm doing it to one side and then the other, and then I'm distributing. So you can use your calculator if you want to do 56 times 7/8. That'd be wonderful if you wanted to do it with your calculator. So this is how it would look if you did it with your calculator, 56 times 7/8. And I expect it to be a whole number. If it's not a whole number, then I know that I have made a mistake somewhere. But it is 49, so hot diggity dog. You can also do it by your head, because you could say this is 56 over 1, and 8 goes into 56 7 times. Now I got 1's in the denominator, and 7 times 7 is 49. So either my head or my calculator gives me the same answer. You can put this in your calculator as well. So it's 56 times 1/7. So I need a 7 down here, and I need a 1 up there. I kind of edited what I had. Times 1/7 is 8, right? And by my head, I can definitely see, now there's 1's in the denominator. This is 8t. And then 56 times 2 is 112, I think, but I'll make sure, and it is 112. And then now it's an easier problem to solve. I want to get the variable on one side and the numbers on the other. Step 3, take away 49. Both sides. Do you notice that when you multiply, you distribute, you do it to all. But then when you add or subtract, you just do it to the like terms on each side of equal, one time on each side of equal. So sometimes people tell me, but you did this 3 times, whereas you're only taking away one side. So you didn't do it just one time, but I really did. And the reason is because it would look like this. So it is really only one time multiplying by 56, but because of the distributive property, so this is times 56, and this side times 56, so you distribute it. So that's why it looks a little bit different. Because of the distributive property, you do it to all. So 112 take away 49 is 63. And 8 divide by 8, both sides. 8 doesn't go into 63 evenly, and in fact, it doesn't reduce either. So 63 over 8 is my answer. T equals 63 over 8. And certainly I could check my answer to make sure that it worked. And it is a good idea to check. So 7 over 8 plus 1/7. The parenthesis for t equals 2. And what are we putting in? 63 over 8. And I plan on just putting this in my calculator like I see it. So my plan is, this is 7/8. Whoops, I put the absolute value. 7/8 and plus 1/7. And parentheses here, and 63. Ooh, I got crazy, didn't I? I didn't go upstairs there. So I need to go out to the side, and so that I can put my parenthesis. Whenever it starts not doing what I wanted it to do, you just push delete and it'll go back. And so 63 over 8, I'm hoping that's going to equal 2. And it does, because the other side's 2. And that means I have the right answer. So I checked it. Okay, so here, there is distributive property on number 11, so I'm going to do it. So this is 6x, so distributing here, plus 36, and 4x minus 24, plus 2x. So combining like terms is next. There's not like terms, but these are like terms, so I get 6x minus 24. And you can kind of see already that there's a problem, right? If I'm trying to get the variable on one side and the numbers on the other, so if I say that this side over here is where I'm going to put the variables, right, and this side over here is where I'm going to put the numbers, I would have wrote that above it, but I didn't have room. You can see that 6x shouldn't be over here, so when I take it away from both sides to get the variables together, that I don't get a variable. That's 0, and 0 plus 36 is 36. And so I wanted a variable over there, and I'm not getting it because of the balancing variables here. And so what I have to look at is is this a true statement? If it's a true statement, then the answer would be all real numbers, and that's the fancy symbol for all real numbers. If it's a false statement, then the answer would be that there is no solution, and that's what I have as a false statement. 36 is not equal to negative 24, and the answer is, that's the symbol for no solution right there. This means none of these is what that means, none of these, which means that, you know, this is not the answer, this is not the answer, this is not the answer, this is not the answer. Okay, then I will mark that. So if x had been equal to 7, which it wasn't, which none of these are equal to 7, then I would have marked none of these. So that's the story on that. Okay, so we have here 7x plus 3. I'm going to distribute 6x minus 6 plus 9. So 7x plus 3 equals, and then that's going to be 3. So 6x plus 3. So I want to get the variables on one side and the numbers on the other. I made enough room where I could put the variable over here and the number over here. So I'm going to take away 6x because that's a variable on the number side. Take away 6x. I'm going to take away 3 because that's a number on the variable side. And you might say, this makes 0 and that makes 0. Isn't that a problem like it was up here? But remember, I said I wanted numbers on this side, and 0 is a number. The problem is I said I wanted variables on this side, and I had 0 plus 36, which is a number. So that was, and it was because of the balancing variables. I don't have them balancing here. 7x take away 6x is x, 1x. X is 0. Nothing wrong with 0. 0 is one of my favorite numbers. So I'm going to check that. 7 times the what plus 3 equals 6 times, and then I'm going to put my what right here, minus 1, plus 9. I'm off the screen, but I'm going to put in 0 here and 0 here, and I'm hoping that this, that's 3, and I'm hoping that this will be exactly the same, right? And 0 take away 1 is negative 1, so this is 6 times negative 1. Of course, I'm free to use my calculator, which is negative 6 plus 9, which is 3. And so, yes, they are equal to one another. 3 is equal to 3, so yes. So x is 0 is our answer. So we did a good job on that. I'm watching my time. I got a 1 o'clock class, and it's 12:50. So I'm going to see what else we can do here. Hopefully I'm still recording. I am 13, so I'm going to use the distributive property right here. I don't clear decimals. I just live with them. So 0.9 times 2 is 1.8x. 0.9 times 8 is minus 7.2 equals 4. And then I like to put a 1 there, but you don't have to put a 1 there. Minus 1x and minus 5. So when the dust clears here, these are not like terms, but over here, these are like terms. So you can get, you'll have negative x minus 1. And now I'm going to get the variable on one side and the numbers on the other. Remember, there's a 1 here, right? And so I'm going to put the variables over here, and I'm going to put the numbers over here. You just got to get them separated. You're only allowed to use, when you're doing this, add and subtract, right? Step number 3. So I'm going to add 7.2, and I'm going to do that to its like term, plus 7.2, and I'm going to add 1x. Add 1x. So when the dust clears, this makes 0, and I wanted variables over here, and I'm certainly going to get variables. I'm going to add 1.8 plus 1, which is 2.8 x, equals, and then over there, I'm going to get 6.2. And then I'm going to put my finger on x, and I'm going to divide by what I see. So I'm going to have 2.8 divided by both sides. And that's going to give me x equals, and I got to pay attention to my writing here. It's getting all squinched up. 6.2 over 2.8. And that's not an appropriate number. You can't have a decimal in your numerator of your fraction and in your denominator of the fraction. The lucky thing is if you have this calculator, well, it will fix it for you. So if you're all in a bunch and whatnot on your arithmetic, well, this calculator will do it. It says, hey, that reduces to 31 over 14. If you do not have a Casio calculator, this particular one is the 300. My favorite one is actually the 115 and the 991, but I like them all, right? I use them all. So these are my favorite ones. The reason is there's a button that when I get to intermediate algebra that I really love. And so anyway, that's my story there. If you had to do it by hand, you certainly could. And so by hand, because this is buried to the 10th spot, and that's buried to the 10th spot, you multiply by 10 over 10, which is the same as multiplying by 1. And then that's 62 over 28. So 6.2 times 10. So now I no longer have the crazy decimal situation. And now I notice the top will divide by 2 as well as the bottom, and that's 31 over 14. So it wouldn't be the end of the world if I had to do it by hand. Certainly could. So here on this problem here, and you can check your answer. And so certainly I should check my answer and put it in. So 2, and then this is 31 over 14 minus 8 equals 4 minus, and then 31 over 14 plus 5. So we'll have this calculator do this one, 0.9 parentheses 2, and then it's times, using the parentheses there, 31 over 14 and minus 8. And so that's that side there, which was negative 45 over 14. All I care about is, are the two sides equal to one another? So this side over here I'll do with this calculator, 4 minus, of course you can just do them one at a time. And inside there I have fraction 31 over 14, and then what was it, plus 5. And I got the same thing. Both sides negative 45 over 14. So both sides are equal to one another. Doesn't matter what they're equal to, just as long as they're equal to one another. And so that means that 31 over 14 is the right answer. Okay, so we're going to give a try to doing this problem. And I notice that all I have is this division of 3. And I have that crazy negative hanging out to the side. And here's what I would do with the negative. We learned in chapter 1 that if you had a negative out to the side of a fraction, we learned that you could put that negative, if you wanted, in the top, or you could put that negative in the bottom. Can't put it both places. And that's what I'm going to do, is I'm going to put that negative with my 3 down there, so that I have x over negative 3 equals 15. And so what's going on here with my x is I don't have any distributive property. I don't have any like terms. I only have one term on this side and one term on that side. Remember, terms are held together with multiplication and division. Watching my time, 55. And so I have one term on the left and one term on the right. So this is a variable and that's a number, so they're separated. So I'm on last thing, multiply or divide by that negative 3. Well, what is that negative 3 doing with my x? It's dividing. So I want to undo it with its inverse operation, which is multiply. I want to multiply by negative 3. So I want to multiply here by negative 3 and here by negative 3. It doesn't matter if I write it on the left or the right. Over there, it matters with division, but doesn't matter with multiply. So this is negative 45. And here the negative 3 and the negative 3 drop out, right? They divide out, making 1x, which is x. So my answer is negative 45. And I certainly can check my answer to make sure that it's right. So I had negative over, and then I had 3 equals 15. And this up here is where I was going to put what I said the answer was, negative 45. And I'm hoping that that's equal to 15, right? And of course, you could do it with your head and see that, oh yeah, it is. But if you're like, oh, tired, you could use your calculator if you wanted, and that would work out as well. And so you see I got 15. So 15 equals 15. And so I'm like, hot diggity dog. So x equals negative 45 over, no, negative 45, sorry. I don't know why I started saying over. So now we're going to do number 15. I don't know if we're going to do number 15 in this video with only 3 minutes to go. Maybe we'll just go ahead and give it a try. So this is 6x minus 15. It would be nice to have this page done. And then minus 2x plus 4 equals 6. And then my minus 1, I'm distributing away, right? Minus 4x and then minus 5. And then I'm going to combine like terms. 6x take away 2x is 4x. Negative 15 plus 4 is negative 11. And on the other side, I have 6 take away 1, so I have minus 4x, and then plus 1. I'm going to put the variables on one side and the numbers on the other. So I'm going to be adding 4x to both sides and adding 11 to both sides. So it looks like I have 8x equals 12. When I divide out here, I'm going to get x equals, let's see, 4 goes in there, so that's 3 over 2. So my answer is 3 over 2, and I can certainly go and check that answer, but I have class almost. So 3, 2, and then this is 3 over 2 minus 5 minus 2 times 3 over 2 minus 4. Ah, that's the right side. And put that in my calculator. Left side. I don't know, right from left. Get over there, pencil. So on this side, I'm getting -5. And on the other side, I'm going to have to put it down here. This is the left. And I'm going to put the right down here just because I ran out of room. Sorry about that. 6 minus, and then 4, and then times 3 over 2 plus 5. And I'm hoping that that's equal to -5 as well, because the right side and the left side should be equal to one another unless I have made a mistake. And I do have to admit that I did really start hurrying. And that's when I make a boo-boo, truthfully. But got lucky and didn't make a boo-boo. They're both equal to -5, so this is a good answer. So I got to go to my class, and then in part 3, I'll do the rest of the problems.